Okay, we'll continue from where we left yesterday. We were talking about the three properties of list, right? Map, filter, and reduce. And we also discussed about the anonymous function, okay, or lambda function. This was the example. We can delete it. So what we said, map is map is a way of applying same logic to multiple values. Okay. So for example, let's say you have currency here. Okay. Or let's say value in, let's say we call it as dollar, USD, let's say. And we add some value. Let's say you have some values. You have 12.15. Okay, 34.2, 13.8, or let it be 13.8. Then you have 9, you have 12, then 45, then 87, then 56, then 78. We'll take some random values, okay? Let's say these are the values. Now we need to convert all of them into, let's say, rupees. Okay, so we will have, okay, in INR, let's say, okay? Now, and because we are, it's the same value, and the logic is, let's say you have to apply this with, one USD, let's say is equal to 78 rupees, let's say. Sorry. So we need to multiply all of these, isn't it? We have to multiply all of these by 78 so that we get this. So, okay, what we would generally, what we would do is, we will use for loop to read a value. Okay. So we'll say for V in value USD. So you get numbers one by one. And then we will say value INR dot append. And then you will say V into 78. Right? And now you get your value in INR. You get value in INR. Okay. So traditionally, this is the process. Okay. So you get values in INR. Okay. But there is a shorter way to do it, and we can do it using map. Okay. And if you have very large value, you can actually see that, map is faster to, convert all of these values than using a for loop. So same thing I can do, okay, this way. So first, okay, I'll write lambda. So lambda is going to take one value. Let's say I give x, right? So lambda, then input values, colon, and what operation you want to perform. Now see, this is an example where we could do it in one line, right? This logic is just one line logic. So we can say here, okay, 78 into x. So this is your input and this is your output. This is what you want to return and this is what you want to provide to the function. Okay. Now, so this is your main function, right? This is your function. Now, I will apply map on it. What map says is, okay, so map takes two parameters. Map is a function which takes two parameters. First, it takes the function itself, the function that you want to perform, and then the value from which this lambda will take x. So value USD, right? This has our all the values. So first we provide function and then we provide the list which has your original values. Okay, so that is it. That's it. But what happens is map will return us a map object. So we need to convert this into list. We want output as a list, right? Like this. So we'll put a list here. So list will convert this map output into a list of values. Okay, and you can say value INR equal to this. See, one line logic, okay, is equivalent of all this. So here I'm saying function, okay, which, what logic you want to perform. So I'm saying function lambda will take x as input and it will return 78 into x. And map should pick values from value USD. So this X will be first value from value USD, then second, then third. Automatically, map will take value from here and put it in here. That's the purpose of map. Okay. And now, okay, you can print this. It should be very similar to the first one. See, exactly same output we have. Okay. So that's the purpose of map. Map is to apply same logic, okay, to entire list. And this, these are used only with list. Map, filter, and reduce are used with list. So you need to have the list of values, okay? And it could be anything, right? It can have, this logic could be as complex, but then you should be able to fit that logic in one line, right? Then you can use lambda and you can use map. Okay. Next, we'll talk about filter. So what did we say about filter? We said filter is to filter out the values, right? So let's say I have a new list. I have a new list, and let's say I have some values. So I have 12, 7, 0, -5, -6, okay, 15, 18, 21, -44, -90, -34, 56, 43. Okay, so let's say we have a new list of values. Okay. Now from this list, I want to filter out negative numbers. I want to have only positive numbers. Okay. So I want to leave out negative numbers. So you have a condition, right? So I want to leave negative number. That means values which are less than 0, I want to ignore. I want to remove from the list. Right. So this is where, one second. Okay, so we have a logic. Based on that logic, we'll filter out the values, right? So again, I'll use lambda. Okay, and I'll use X. Okay, so X colon the logic. Okay, now the logic here is for either true or false. Okay, so in map we gave a formula. In map we gave formula. Okay, so formula is to calculate. It calculates the value, right? Output here. But here, because we're talking about filtering out, okay, so our logic should return either true or false. So I'm saying X greater than equal to 0. So when is X greater than equal to 0? For positive values, right? So this should return either true or false, right? For filter, it should return either true or false. So you have 12, okay? Now 12, of course, will return positive. 7 will return positive. 0 will return positive, true. -5 will return false, right? Because -5 is not greater than or equal to 0. So, okay, so this is the logic, okay? So in filter, your logic should return either true or false. Okay, now same logic, okay? So here we'll call filter and we'll say lambda, and here we will pass the list, okay? So we'll pass new list. That's it. This should also returns a list. So we need to convert this into a list. And then you'll say output list. Okay. And then you print values, okay, or filter, right? We'll call it as filter. And output list. Okay, so see, all the negative values have been removed from the list. Now, let's say, okay, another logic, okay.
One second, Swapnil.
Yes.
When we say least and then square, the round brackets filter lambda. Okay, basically we
Wait,
are,
wait, 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 wait. What is round bracket? Why are we using round bracket?
yeah, that's what my
No, no,
question.
I'm asking you, why do we use round bracket?
Uh, like it's a like when either it is a function or a tuple.
No, 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 no. Hold on, hold on. Is this how we use tuple?
No.
Right? So how can this be tuple?
Yeah, so basically, but least should go in with square brackets, right?
List, this is a function. This is not a list. This is a list. Do I
Huh.
put list here? No, this is how you define tuple or a list, isn't it? Or
Yes, yes.
any variable. This is a function.
Huh.
This is a function. And if you remember in the set we discussed, or even in the tuple we discussed, you can convert a tuple to list, you can convert a set to list, you can convert tuple to set, you can convert tuple to list, right? How do you convert list to tuple to list?
Uh,
How did you convert tuple to list?
I'll have to revise that.
List is a function. List of tuple will be tuple. See, that's what I'm saying. You need to revise, guys. We can't move ahead if you don't revise. So this is tuple. This is how you define tuple. This is not how you define tuple, right? And second thing, this is a tuple. And if you have to convert this into, let's say, list, you say list of T1. This is the function we use to convert into list. So list is a function which will convert your linear data structure into list format. So here, if you say T1 dot, you see these are the functions that we discussed under tuple. But now if you do next line, if you do T1 dot, see these are the methods that we used under list. Yes? So list is a function which will convert into list. Clear? So
Yeah.
here we are talking about filter, which is a function which will do the filter job. And this is the list which will do the list job. That means the entire output from filter, which will be an object of filter format, will be converted into list now. So if I don't give list, okay, you'll get an object value, okay? So if I remove list and when you do the output, okay, so this is the filter object, okay, and this is the memory location where the object is kept. So this object I want to convert into list. So I will say list here. Right? And then you get list. Make sense?
Yes.
Yeah. Okay. So we'll move ahead. Okay. Another example we'll take before we go to reduce. So, okay. Now here, let's say I want to find values which are divisible by 3, let's say. Correct? So how do we write that logic? How do I change this logic to filter out all the numbers which are divisible by 3?
X X reminder is equal to 0.
X modulo 3.
Modulo 3, and
Single equal to
X
double equal to.
double equal to.
Double equal to, right? We are checking the condition here. Right. So now you see, you got all the values which are divisible by 3. Okay, 0, 12, 15. But you got -6 and -90 also. Correct? And let's say we don't want negative numbers. Then and, correct? And x greater than equal to 0. Okay, so you can combine multiple logic. Okay, ultimately this entire stuff should give you either true or false. The way you should write this expression is that entire expression here should either give you true or false, nothing else, right? So you can filter out negative numbers as well as filter out values which are not divisible by 3. Okay, so that's the job of filter. Now we'll talk about the third property, which is reduce. Now, Reduce is not directly available for us. We need to import something called as fun tools. Okay, so when you import fun tools, okay, you will get access to reduce. Map and filter mostly we use, okay, so that's available, okay, and reduce does not have much of a use, okay, so we don't use it that often. So we have something called as func tools. So I'm going to say from. So same again. See here I can say import func tools that we discussed the other day, right? How to import modules. So import func tools. Now if I say import func tools and I say I call it as I'll give a alias here. Okay, so import func tools as FT. So now you say FT dot. These are the functions. See reduce. You have reduce, you have cache, and these are other functions inside func tools. But if I want directly reduce, then I will say from functools import reduce. Correct? So there are two ways, right? One is directly import all the functions from functools module, or you import only the reduce function from here. Now, when you import functools, okay, then we have to use the function name. If you have to call that function, you have to use ft dot, right? Ft dot will give you access to reduce, ft dot reduce. But in this case, you can directly say reduce. You can directly use reduce. Okay, so let's say we'll use the first method. So I'm going to comment this out. Okay, so let's say you have same new list, okay, and I want to find sum of all the values. Sum of all the values in this. So the logic is lambda x, y, we have to give two values, x and y, right? So lambda, you give x comma y, okay? And then you add them together, x plus y, right? So this is the input we are giving, and this is the return I want. I want sum of all these values, let's say. Okay? So now this we have to pass for reduce, right? So we used ft, so I'm going to say ft dot reduce, and we will pass the function and the list of values. So usage is exactly same. You see, function comma the list, right? Map, filter, reduce. All three functions will have first the function, okay, the logic that you want to perform, and the values, list of values. Okay, just that reduce is not directly available. We have to call functools. Okay, now in this case, we don't have to convert into list or tuple or anything because reduce will give us only one value, right? What does reduce do? So if I say here, okay, here I have x comma y, right? And then I'm giving this entire list here, right? So we are saying x plus y, right? That's the logic we want to perform. So what it does, okay, again, it will run multiple times. First, it will take these two values. X will be, okay, first run, X is going to be 12, Y is going to be 7. So you get 12 plus 7. That's the first run. Now, second run, what happens? The previous output that you have got, 19 will become X, and next Y will take the next value from the list, 7. No, sorry, 0. Then what happens? X becomes the output, 19, plus Y is next value from the list, which is -5. So this becomes 14 plus -6. Okay, so now we have 8, right? 8 plus 15. So it goes on like that until you get one single value. Okay, so I can say val equal to, and then you can print the value here. Val. Okay, so answer is -7. So same, so it's like you are trying to perform operation within the list. Okay, you can add, multiply, and you can add any logic. Okay, whatever logic you can add. I want to add, I want to multiply them or I want to divide them. So what happens for the first time, X will be the first value, Y will be the second value. But second time onwards, X will be the previous output and Y will be the next value. So how many times this loop is going to run? How many times this iteration will run? N minus 1 time. If we have n numbers here, it's going to run n minus 1 time, because first time you're taking 2 and next time you're taking 1 by 1, right? So, okay, it will run n minus 1 time. Makes sense? So these are properties of list. You can use map, filter, reduce. And here you need to use function. That's why we are doing it after we are done with function. Okay?
So map, filter, reduce, we can use only on list. That is.
Yes, yes. You can only, the input has to be a list. That's when, see, you need more than one value, right? This is iterative in nature. It has to run over set of values. So which one will give you the list of values, right? So list is the only linear data structure. Dictionary or set you can't access each member. Dictionary is not linear, right? It has key and value.
And the lambda we get under functools only.
Lambda we get under what? Sorry?
Because when we use a lambda function, right, inside
Mhm.
that function, functool.reduce under reduce function.
Mhm.
So that lambda is actually a different module in itself, right?
Lambda is a keyword which performs like your function operation. Okay, so lambda is a keyword which performs function. Okay, so here, okay, it's a one-line function. It's a function which can be written in just one line. Okay, so so this is the keyword to indicate to Python that you are going to use lambda function, and it has lambda followed by the input parameters, and then you have output parameters. So lambda this is same as writing def some function. You don't have to give a name also, because we are going to use temporary. It is used and then you forget. Otherwise, you can give a name also. I can say ABC. ABC equal to lambda this. That means you are saying def ABC. It takes two parameter X and Y, and you are saying return X plus Y. Okay. So this is, this is the, full form, you can say, of this one.
But
Okay.
we
And
need-
sometimes we don't even have to give, like in that case, we don't carry forward if you want to save this in a variable so that you can use it again and again and again, you can say equal to ABC. Otherwise, you don't have to give this. You can directly use this like in map or filter or reduce.
But we need not import it separately, like import.
No, it's a keyword. No, you don't have to import.
Okay, got it. Thank you.
Perfect.
Sapni,
Yes.
Sapni, is it possible to provide some examples where these will be used, like
These are
maps?
examples, no? So let's say, you're flying from New Delhi to New York, okay? And let's say when the flight has to land, right, they have to provide the details of the aircraft, right? At what altitude it flew, okay? So now, in India, you use meters, and US, you use feet. So same airline, when it lands at New York, they have to give details in, let's say, feet, right? And when you land at, say, Mumbai or New Delhi, you have to give the details in meters, right? So flight will capture data in some format, but when you have to submit it, you have to convert it into different form, right? So let's say if your aircraft captures in feet, then you'll submit exact same data at New York airport. But when you land at Mumbai, you have to convert this into meters, isn't it? So you'll fly over, let's say, 100 cities along the way. So you'll have a list of 100 values in meters. And then you have to convert into, all the 100 values has to be converted into meter format. Okay, you are doing some financial analysis and you are trying to get data from various countries, right? So you have, let's say, you're looking at top 10, let's say top 10 or top 50 banks, for example. Now, these banks will be in different countries, right? If you get their annual income data, it will be in the local currencies. But if you have to analyze, right, into convert them into common currency, right? So then you will convert everything into, let's say, US dollar, right? So you have INR, you'll convert Indian bank, you convert into the USD. You have bank in, let's say, France, you have to convert that from Euro to USD. So you're applying same logic over multiple values before you start performing operations. One second.
Awesome.
Okay.
So,
Okay.
so
Yeah.
just to summarize, right, what I understood, right? The same value can be used multiple times. Like, for example, those are USD, for example, values. If I want to convert into INR, I can use it with that logic. Or if I wanted to convert into any other currency, I just need to factor in that, right?
Correct. So from Python perspective, it's about, same logic if you have to apply over list of values. Same logic you want to apply over list of values. Okay. So let's say you have list of values in euro and you want to convert them into USD. So the logic that you'll apply to convert one value from euro to USD is same, right, for all the values. So that's the situation where you can use one of these. So same logic over
Awesome,
large
awesome.
set of values. Same logic. You want to convert feet to meter. You have 100 values in feet and convert into meters.
Oh, it's much faster and easier, I think,
Faster,
using
easier.
that map, right?
Exactly.
Performance will be better. Yeah,
Performance will be better, and the line is also like one line, right?
awesome.
It saves your time to code, times to understand, time to
Yeah,
fix. Shorter code, okay, one, it takes less time to write. But more than that, the code will be in use for 10 years, 20 years, right? If somebody has to come and understand, somebody has to come and edit, it will be easier for them to understand and edit, right? So that's why we prefer shorter codes. Writing
makes
is
sense.
one-time
Yeah,
job, but then editing or going through it, maintenance, what we call, will go on for years, right? So it becomes easy to maintain.
absolutely. I think that's when they factor in, okay, did we use the performance? Like what happens, there's a heavy code, right? So
Yes.
the performance needs to be reduced. So they go and reduce the code as much as possible. And this is one such example we can use map,
Yes.
right?
And correct. And see here you have maybe what, 12, 15 values. You may not see that kind of improvement in performance. But if this was
Yeah, what of
1,000,
many crows? Yeah,
yes,
makes sense.
right? Then it becomes much simpler. And when you do data analysis, right, obviously you'll come across thousands, hundreds of thousand values. Then it makes sense,
Yeah,
right? Now
basically
let's say you have a
optimizing.
column.
Yep.
You have a column of data which is in feet and you need to convert them into meters, right? So again, this would be the best way to do it.
Thanks, Swapnil. Yeah.
No problem.
Sir,
So,
hello.
yes,
Sir, if the list of value is there, then I repeated again that values. Then how can I reduce?
if the values you want to say repeated stuff, right? You can repeat it, doesn't
I,
matter. No, list can accept repeated values. Set will not accept, but list will accept. So
list
yeah, so it will be twice. So you get 2 times. You get
two
12, 15,
times.
18, 21, 12, 0, 15, 18, 21. Yeah, it doesn't matter. It does not List is not affected by repeated values, duplicate values.
Okay.
Only sets are affected by duplicate values, right? Okay. Yeah,
Thank you, sir.
no problem. Okay. So now we'll move on to new topic. Let's introduce this topic. This is called class and objects. Okay. So we spoke about class and objects before, and I said that, we'll discuss more about it when we go there. Okay. So what is class? Okay. We'll talk about first class, right? Now, when we say Apple, okay, I like to talk about Apple. Let's say when you say Apple, right? Now, we all know what Apple means, right? Because we associate some properties with Apple. Now, if I tell you that I'm eating apple, you won't be surprised. You said, yeah, so what? But if I tell you that I'm playing cricket with Apple, okay, for Jacqueline, if you're playing baseball with Apple, you'll be like shocked. What? How can you play baseball with Apple, right? It's not possible, right? You don't associate playing with Apple, right? So similarly, when we have to deal with, some values, okay, we have to first define, okay, some properties, some values. Now, there are two ways of doing programming. So far, what we've been doing from day one till today was, we call it as functional programming or function-based programming, right? So let's say, you write a function, for example, this one, you write a function, okay, you have X and Y, and then it returns X and Y, and then it forgets what is X and Y. But reality is not like that, right? When you talk about real world, there should be some origin of X and Y, right? So what we do, okay, and let's say, for example, we define list, right? So when we say list of values, 2, 3, 4. Now what Python considers this as a class. That means it says that all these values that you see together, they belong to one form, right? Just like when you see apples in the grocery store, you say that all these are apples, right? So all these values belong to one form called list. And why do we need to understand? Why do we need to know that, okay, these are apples, these are bananas, these are human beings, these are cars? Because we associate some properties, right? If I tell you that, okay, connect on Zoom, right? You understand what it means. You understand, okay, this is Zoom and this is how we need to connect. Because I don't have to explain you every time. For example, let's say if we never had name for apple, let's say nobody had named fruit apple. Now, every time if I have to talk about apple, I have to explain you, isn't it? This is it. By giving it a name, what it becomes easy to understand. You are able to, I just have to use that name. I just have to say, okay, create a list. And okay, this is what I mean, correct? Otherwise, if we do not give this a name, okay, a list or something, then it becomes very difficult for me to explain and it becomes very difficult to use it, right? So class, you can say, is a name that we give to a group of values or properties. So when I say car, for example, okay, now when I say car, so what are the properties that car will have? So car becomes your class, correct? Properties will be number of wheels, right? Number of color of the car, correct? Company, make of the car. And there's some properties like driving, parking, right? So if I say I'm parking the car, you won't be surprised, right? Because you associate parking with car. Okay, you associate driving with car. Now, if you look at the properties here, number of wheels, okay, if I ask you how many wheels my car has, so what will your answer be?
4.
4, right? Because we associate wheels with 4. But if I tell you what is the color of my car, first of all, color is a variable for car or not? Yes. You won't be surprised. How can car have color, right? No, car has a color. So you will not be surprised. But here you will say, I have not seen your car, so I don't know. Okay. So class is a group. Object is the actual usage of the class. Okay. So when I say apple, you understand what apple is, that is the class. But if I'm holding a specific apple, that becomes the object. How many objects can you create of a class? Infinite, right? Apple is not just one in the world. There are millions and billions of apple in the world, right? So class is always one. You cannot have another fruit called as apple. If you discover new fruit, you can't call this as apple because apple you already mean something else. So class is a group which has properties, which has some variable associated with it. Okay, but there are some values which are specific to the object that you are holding or you are talking about. Example, car or make, these are not common for all the cars, but number of wheels, okay, number of steering wheel, okay, that is common to all the cars. Okay, so you have properties which are common to car, the class, and there's some properties which are specific to the object. For example, if I ask you, okay, which apple am I eating? You have this different types of apple, right? Fiji apple, Washington apple, Indian apple, right? If I ask you what apple I'm eating, can you answer it? No, you can't answer it because that is specific to the apple which I am holding. But if I ask you color, probably you can say color of the apple is red because all the, except let's assume that we ignore green apple for a second. Then color you will not ask me, but you'll ask me which apple is that, right? You mean to say, from where have you got that apple? So class, okay, when we define a class, see, so far we've been using inbuilt classes. We've been using list, tuple, dictionary. In fact, Python treats even integer float as a class. Okay, generally, if you look at Java, Java doesn't treat basic data types like integer float as class, but Python treats even. If you're in the class, please don't talk, or you can go on mute and talk. Not able to mute. Yeah, thank you. So I was talking about class, right? So list, tuple, dictionaries are saying that Java does not treat basic data types. Basic data types are your float, integer, complex, Boolean, string. Those 5 things that we discussed earlier, those are your basic data types. Java does not consider them as class and object, but Python even considers those basic as class. Everything is class in Python. Class means there is a predefined meaning. When I say I'm using an integer, you know what I'm talking about. Just like when I say I'm eating apple, you know what I'm talking about, right? So far we've been using inbuilt classes. Okay, they have a predefined meaning and they have predefined properties. Now we will create our own class. So I said class is defining it, right? When I say apple, it doesn't mean that you get to hold an apple or you see an apple. It means that I'm talking something about imaginary thing. But when I say I'm eating, that for that you need to hold an apple. So to understand what class is, you don't have to use the class. You just define the class. But when you have to use it, you need to create an object of the class to use it. Okay, you need to create object of the class to use it. For example, if I say class book, so I'm defining a class called book. Okay, so this is how you define class space book, and then you give colon. Under colon, you define all the properties. Okay, so class will have properties like so what are class specific properties? Which is at class level, at group level. Now, if I talk about title of the book, number of pages, cost, these are not at class level, these are at object level, right? Not all books will have same number of pages. Not all books will have same title, right? So I need to first, okay, let's say I talk about number of books that you have. Now, number of books, okay, is class level, right? Because it will remain same. If you have 100 books, okay, it remains 100 book. If I ask you how many books you have, you will not say, okay, which title? You'll tell me I have 100 books, right? That's a class level. I say 0. Number of books equal to 0. So this is your class level, okay? Now let's say I define a function called reading. Okay. Now if I ask you, which book are you reading? Now, which book are you reading? Is it a class level or a function as a object level? It becomes an object level. Okay. So let me first show you how to create a class, and then we'll talk about class level and function level. So here I'm saying print, I am reading a book. Okay. So I created a class called book and added two members to it. Okay. We call them as members. This is your variable. This is how we define variable. And this is how we define a function. Function in a class is called as method, right? So we call this as method. But exactly like function, but function, when you put independent function, it's called a function. And when you put as part of a class, they're called as method. So this is a method. Okay. So class will have variables, more than one, of course, and methods or functions, right? So this is a simple class book which has two members. One is variable, one is function. Now, if I have to use this class, right? I have to create a object. So I'm going to say B1. B1 becomes object. B1 equal to book bracket open and close. So this is how you create an object. Okay, so I'll say creating object of class book. And you can have many objects, right? B1, B2, B3, B4, B5. I can create any number of object. Every time you are using, you have to create an object. Okay. But defining the class will be one. I cannot have one more class called book, right? If I define two as apple, you'll get confused. What up, isn't it? Apple will be only one fruit, right? You don't define more than one as apple, but you can use, you can consume, you can eat, you can, multiple apples. Those are your objects. So B1, when I say B1 equal to book, what it means is B1 will get entire properties of this class. So when I say L1 equal to list, okay, 2, 3, 4, L1 gets, okay, entire properties that which is defined under class list. So there's a inbuilt class list which is defined, and all the properties. So functions that list has will be available to L1. Similarly, if I say here B1 dot, that's how we call methods or function, right? So see, you have number of books and reading method, both are available for you to use. Okay. So now when I say number of books, if I print number of books, what will I get? I'll get 0, right? If I call B1 dot reading, okay, you get I am reading a book. So whether I say B1 dot, B2 dot, B3 dot, B4 dot, okay, I'm going to get same answer, right? Because this is what I have defined here. But can we change? Of course we can change. So this is how we create a class. So class is a group. Okay, now in programming term, class is simply collection of variables and functions. That's it. Okay, related variables and functions, you put them together and you call it a class. But the purpose, the background that now you know, right? Why we define a class. So for us, for Python, it is simply putting variables and functions together. So there are two types of members, right? For a class, variable, method. That's all. Now again, they can be class level variable, object level variable, class level method, object level method, right? So you can have class level variables and methods, correct? And then you will have object level. Okay. Difference is class level variables and methods will give you same answer for all the objects. Object level variables and methods will have different answer for different object. So this is very specific to the usage, and this is common for all the members. Like color of apple will be common, right? Number of tires, number of wheels in a car is common for all the cars. But color of the car is object level variable. Okay, because that will differ for every car. Okay. So we'll stop here. We'll take an example tomorrow. Okay. And we'll see all these 4 types. Okay. Class level, object level, variables and methods. We'll see how we use them. All right. Any questions?